Good afternoon and welcome to this Convergent Science Network event when we're celebrating women in biomedicine. Now, the talents of women in science, technology, engineering, mathematics and medicine, or STEM, are vital to the future of Australia's health and economy and our ability to solve global challenges. Yet it is no secret that women are sometimes quite poorly represented in the STEM workforce. So with this Convergent Science Network series, Women in Biomed, we explore the careers of women in biomedicine and biomedical engineering. We celebrate the successes and we share their research and experiences. We'll also discuss how to encourage more gender, diverse and female students to study science and stay in science and the challenges that they may face. Today, our speakers are Dr. Jennifer Zenker and Associate Professor Mirana Ramialison, both at the Australian Regenerative Medicine Institute. Hopefully you've had a chance to watch both their videos introducing themselves and their work. Just to quickly recap, Jennifer is an emerging leader in the field of cellular architecture of pluripotent stem cells, and Mirana leads a multidisciplinary team of computational and molecular biologists to investigate the genetics of heart development and disease. And rather than me explaining their incredible research, I will hand over to them. So maybe we'll start with you, Mirana. In your video, you said that only 2% of our DNA encodes genes, while the other 98% was originally thought of as junk. But you and others have shown that it's actually full of information and can switch genes on and off. Could you please explain to us how some parts of our genome can regulate others?
Yeah, this question is basically what I'm passionate about. How do they do this? So the first thing is to find out that it was not junk, but then how does it work? So in our lab, we've designed this software and these tools to try to, first of all, predict which bits of the DNA are actually functional. And the next stage is to see how do they actually perform this function. So it starts to be clear now that the way they do this is that these bits and pieces of DNA that do not encode for genes actually physically interact, so they form loops. To interact with the genes they are turning on or off. So this physical interaction is driven by molecules that we call transcription factors. And these are the specific molecules that we're really interested in and trying to identify how and which ones are binding to this region that we call junk DNA to turn certain genes on and off in certain tissues at different times. So that's the secret. They do interact with the genes and these switches turn them on and off.
Cool. And how does this interaction with the genes and switching them on and off sort of relate to health and disease?
This is a crucial question because we don't know the mechanism. We don't really understand what is the contribution to disease. Nonetheless, when you sequence the genome of patient with disease, and for example, congenital heart disease, most of the mutation that we see in the patient fall into these regions. So we don't understand the consequence of these mutations, but they actually fall into this region that we don't know of. So this is for me the crucial part where I think understanding how this connection happen will help us to understand what is the origin of the disease. In the case of congenital heart disease, 80% of the babies which are born with this disease, which is a heart defect, actually don't have a genetic cause. And we believe that the mutation that they have in the genes is actually falling into these non-coding regions. So by identifying the function of these regions, we can interpret the genetic information of these babies, and then we can give a better diagnostic. So it's a major implication for their health and their diagnosis.
Yeah, well, that's super interesting work. And, the fact that you're looking at 98%, 98 versus 2%, that's quite a big difference.
There's so much potential in there. That's right.
Yeah. So we might leave it there for your research, but audience members, if you do have any questions about Mirana's research that you want to touch on later, feel free to ask those questions. I might ask Jennifer, we are incredible organisms. We're made up of around 30 trillion cells and we start from one. So Jennifer, how does a single cell become such a complex human being?
This is an excellent question. And yeah, we are incredible machines. I mean, there are a lot of people really enthusiastic how a car works, how a laptop works or so, I'm really fascinated how actually our own body works. And then knowing that all this starts with one single cell, a round ball that looks basically as simple as that. It cannot be much more simple looking from the outside, yeah, and so small, like 0.0007 centimeters. And then it becomes a structure like me, like you. Just how can that happen exactly? So basically, there are two key processes you can imagine must happen. I mean, there are more, but the key processes are, first of all, you need more. So from one side, you need to amplify the number of cells. So the embryo, it grows them from 1 cell to 2 cells, 4 cells, 8 cells, 16 cells, and so on until it reaches a few trillion cells. But that cannot be all. If that's all just pure amplification, we would be just like a mulberry or something like that, just some balls put together. So the other step that needs to occur is obviously these cells need to become different. They need to specialize from a very unspecialized cell, the fertilized oocyte, to become a neuron, to become a muscle cell, to become a skin cell, and all the other cell types we are made of. And this is called a cell differentiation. And this occurs step by step. It's not suddenly within a second you have a round cell and then suddenly you have a beautiful nerve with all the extensions and so on. So it's a slow process, and it's important what happens inside in the cell in that moment. So not only the outside is basically the result of what happens inside. So a lot of people have really studied what is going on with genes. A lot of amazing studies have really shown how genes are differentially expressed during development. Some gets turned on, some gets turned off, and so on. But there's a second component we should not ignore, and that's obviously what I call the cellular architecture. Inside of the cell, you have structures like a framework, like every building needs a framework to have a certain shape. Such a framework also have every cell inside, which is called the cytoskeleton. But this cytoskeleton, the framework inside the cell, is very dynamic. It can be remodeled at any time when it's needed. And it also basically guides all the other components you can find in the cell, which are called the organelles, to be positioned exactly there where they are needed. And that's exactly what I try to understand when the cells start to differentiate what happens with the cellular architecture, so the components inside of the cell, when they really differentiate into a specific cell type.
And Jennifer, why is it so important that we do understand development of cells and particularly the cellular architecture as we develop?
Very good question. At the first view, it might obviously look like very basic research. Yeah, just knowledge, gain of knowledge. How does it work? Which is true, but this is basically the basis to really also be able to advance applied applications or research. So just imagine if you have a car, a very simple example, if you have a car and it breaks down, only the person who knows, basically the car engineer, how it was assembled at the first place knows how to repair it. So we need to know this very basic knowledge, how a human organism or any other animal also gets really assembled at the very first place in order to be able to repair, which means when we get sick or when we have an injury or after an accident or so, once we know how it was made at the beginning, we are able, hopefully also to repair it, to replace it, or to regenerate. So that's a very important knowledge we need to know. And another very obvious benefit, and medical benefit, is obviously when we understand how the earliest days of development really occur, which is a quite difficult time point to understand because it's obviously inside the mother organism usually. This is exactly the days where also all the treatments in the in vitro fertilization clinics occur. So there's a big potential to really improve in vitro fertilization. And this can go far beyond the human organism. Obviously, we think about human to improve there or to reduce infertility. But we could also produce maybe livestock maintenance, and so on. So there are a lot of benefits we can get from that.
So both of you are doing quite fascinating research. I might ask about your careers. So my first question, and maybe we'll start with you, Mirana, what motivated you to get into the field of genetics and congenital heart disease, and what sort of inspired you to go down that path?
I think it's been mentioned in both of our videos, there's no secret, it's the passion. It's just basically, I have the opportunity to do as a job, something that I really, live by. So it's like solving a puzzle. So if you're puzzle addicted, you like to do puzzles every day. So that's how I see science. It's just something that, keeps me going, trying to understand, how we work. And the maths behind it, it's really what intrigues me, because biology and mathematics were really two subjects I was interested in. And I do believe that, we are beautiful machines, which means, from my engineering perspective, there are some engineering, mathematical principle behind the formation of our bodies. So I think it's far more complex that we can understand, because there's just too many parameters, too much data. But this is why, what keeps me going. I think by creating new tools, pushing the boundaries in terms of technologies and our ability to process all of this data, we can understand the puzzle of life and how we form our bodies and how we become these beautiful, organisms that we are.
Yeah, and there are always more and more questions to answer the more you learn.
I think, a common point is that we don't know much. Despite being, in the 21st century, we don't know much.
Still a big puzzle. Jennifer, what about yourself?
As Mirana said, it's really a passion. If you're a scientist, you need to be really passionate about it. And for me, it started very early on. I a little bit mentioned the story how I started really finding my own passion for biology. It started as soon as in school. So in Germany, the school system is a little bit different, but in Germany, during the last 2 years at school, you can select yourself your main subjects. And so I have an older brother, and he chose biology, and he had an amazing teacher. So he had already in school was able to do his own experiments. So one day he brought the fruit flies home. So stocks of fruit flies, these little flies that are hovering around your fruit balls, and you usually hate them. You always try to get rid of them. So obviously, my brother was excited. I had no idea what's going on, and my mother was not excited, to say the least. But it really totally hooked me. Yeah, when he told me what he wants to do, that really looking at the flies, which usually mostly have red eyes, he was supposed to keep them crossing in his own room and so on, in order to get a fly with a white eye. A typical Mendelian experiment you learn probably firsthand in the school, but our entire family was somehow involved. So Sunday morning, the first thing, we didn't care about breakfast. We went to the flies, made new yeast, and so on. We ignored everything else. And from that day on, very easily said, fruit flies are more than welcome. Then from there it continued, obviously. I wanted to do the same. So I took the same main course, biology, with the same teacher, and he provided us so many possibilities. He went with us to a research institute. I did my first PCR there, and I didn't want to leave. I wanted to stay in that research institute and sleep there if I can. So yeah, basically from there on, it was clear what I'm doing. And obviously it was the best choice.
A house of flies, that's what it all started with. Jennifer, so often we talk about a linear or a non-linear sort of career pathway, and I guess like your sort of typical linear career in academia is you do your undergraduate studies, and then you potentially do a master's, and then go into a PhD and postdoc and so on and so forth. And that's sort of regarded as a straight pathway, whereas there are so many people now who don't follow that, I guess, typical pathway, and it might be even becoming more common to stray off that. Would you consider your pathway being fairly straightforward?
Written on the paper, it looks like that. when someone asked me on the CV, yeah, I did my PhD, did the postdoc, became a group leader. But I doubt, even so for most of the people, it is a kind of written like that on a CV. It's very rarely the case. You really face a lot of obstacles and other things you face, you need to overcome to really get there. I mean, for me, yes, I did my PhD. I moved to Switzerland to do my PhD there. It went all smooth and so on. But also there are some private things happening you never talk about, and you really, yeah, I mean, you deal with your own life in that moment. I mean, for me personally, I really never talk about it. But at that moment, in the middle of the PhD, my mother was diagnosed with pancreatic cancer. And I was in another country, but I was the only carer in that moment. So obviously I had to juggle that. So I was commuting every week between Switzerland and Germany. I wrote my thesis in a train, basically. But that's obviously something I would never, ever put out. I mean, that's not, I would say, it has any hearing into your work, but it does, obviously, at the end. So I finished successfully my PhD well in time, but obviously I stayed a little bit longer because, yeah, it was the time where my mother was passing away. So I had to wait until I was able to continue my postdoc. But I did. So I went then into my postdoc and I thought, okay, everything is good. Turns out well. But then 1 year my postdoc, I moved to Australia in that moment on my own. I had no idea where I am. I didn't know anyone. The first night I arrived, it was dark. I just got the key, went into an apartment. The next morning, I even didn't know where a supermarket is. So, but I settled down. I found a new life. But after 1 year, my group leader says then, okay, he's shutting down the lab. He's moving now to Singapore. So that was obviously another situation where I had no idea what I'm doing. I just thought I had found a new home or something like that. And then, yeah, what am I doing? At the end, obviously, yes, I decided to move as well to Singapore, but for the only reason because of the science I did. I was so passionate. I gave up everything again. And I went there in order to be able to continue my science. And that's really also in Singapore. It's a completely different life. And there especially I faced the major differences I have ever faced in my life differences between men and women. So in science and also in private life. So there was really, women were really heavily overlooked there in science. They were in no leader position, and also in the lab. I was not sitting in a lab space. I was sit at the other end of the aisle, which is more a walking through room where people had their lunch and so on. So there was a very clear difference between men and women. But that's obviously something that should not affect you if you're passionate about that. I knew when I can deliver my work, then new doors are opening. And that's all obviously I concentrated at the moment. And it paid off. At the end, at one point, hard work, in my opinion, pays off. It takes a while, but it gets you there. And then, yeah, luckily now I'm here where I always dreamed of to be here. And yeah, saying that, yeah, it looks straightforward, but it definitely wasn't.
Yeah, thank you for sharing that. I think you've touched on a couple of points that I want to raise later as well. And, clearly everyone's experiences are so different. And I think that's an exciting thing about this particular series. We're hearing from different people who have different lived experiences. So we'll definitely come back to those points, Jennifer. But for Mirana, you are in a field where you've sort of brought multiple fields together and, everything's sort of interdisciplinary. And I was just wondering, what about your career pathway? Has that been sort of more linear or non-linear, crossing over?
Yeah, I mean, one common point with Jenny is definitely, every experience is different, and when we write it on a grant or a fellowship or sometimes on biographies, it sounds, wow, it's just going straight forward. But I do agree with Jenny that the reality of it is it's not like that, and every experience, is unique. And I think it's good that we have this conversation, that, frank conversation, saying, it looks glossy on paper, but talking about, the different obstacle one had to overcome to get there is also very important. I was not destined to do science. I was trained as an engineer, and my first job was to program a database. It was just luck that the first job I got was in Japan, was in a lab. I did not know what a research laboratory was. I was hired to make a database for them. But again, this passion, right? Like I'm passionate about computers and about data, and I was interested in the data that the people were entering rather than making the database. So that what led me to do a PhD. I remember my supervisor in that lab. I was telling him, I'm making this database, but look at this data. It's amazing. These are embryos, and look at the genes. They're expressed exactly the same way. And why do you think that is? And just look at me and say, just quit your job and do a PhD, because if you start asking questions, it's not going to be good for you. So I think that's it. And my career was really driven by that. Like, what next? And the myth that we know what we want to do is this is so not real. I didn't know, what I was going to do next. So I didn't know I was going to do a PhD after the end of my PhD. I didn't know whether I was going to do a postdoc. I did know that, I really enjoyed this job, but, I just wanted to continue the science, whether I could do a postdoc. Even less, starting your own lab, as Jenny mentioned, this is so daunting. Are you ever ready to start your own lab? I just follow again, the research. I put in a grant that I was really passionate about, a project that I really, wanted to do. And that's how I got my first funding to start my own lab. So I think having an honest conversation, saying just follow maybe, what you think is right at that time in your career, and don't put pressure on yourself thinking, I should be a lab head now, I should do a postdoc now. It has to start with something you like to do. Otherwise, there's so many obstacles that if you don't, have this conviction that that's the thing you're passionate about next, it might not work. So yeah, for me, it was really like about the job and what needed to be done.
Thank you for sharing that. Both of you have mentioned passion, and passion being like a driver in your research. Biomedical research requires passion and dedication, but that can sometimes mean that you end up working beyond the usual 9 to 5 hours, and we tend to go a little bit crazy in terms of our mind just, completely being dominated by research. So Jennifer, you must spend hours training and coaching swimming and triathlon. So if you haven't checked out Jennifer's video, Jennifer also does triathlons. How do you balance your training, your coaching, as well as your research?
Yeah, Katrina, thanks for mentioning that. Yes, indeed. I'm a competitive triathlete, so I spend maybe 15 to 20 hours per week training, which is basically more or less another job on my side, and I take it obviously very serious. It's actually balancing out quite extremely well. So obviously the key is to be super well organized. So I always have exactly my training sessions given at a certain time, and I build everything around and so on. So but for me, it's really, the training is really where I obviously take a break from science. Otherwise, I would probably do only science. But it's actually always when I have like a question in the lab I don't know the answer to, or a problem where I don't know how to solve it, I never find the solution for it when sitting in the lab. When I'm in the gym, when I'm on the bike, suddenly I have an idea, say, yeah, that's it. Like, that's how I can solve my scientific question. So sometimes you need actually the distance really, and then these ideas comes up. So this is really for me a perfect balance. Obviously at one point you really like trying to get everything out of your brain when you're sitting in a lab, but then you shut off your brain and then you really use your body. And this physical activity, this gives me all this strength, power, and endurance to really also work hard. It's not only physical strength, endurance, it's really also the mental strength and so on. So really, when there are really problems coming up, I know I can handle it. I can stay calm and just take my time and to find a solution, and I don't like go crazy and then think, oh my God, no, it's the end or something like that. So I know how to deal with difficult situations in very different aspects. And that I think really helps me a lot, but also really the really the drive and so on, and really working long hours, and really this balance overall helps me to be a good scientist.
Yeah, absolutely. It's about sort of finding that balance and making sure that you take breaks. Mirana, your situation's a little bit different in that you have a family to take care of. So how do you find maintaining a work-life balance? Is it challenging? Is it doable?
Which balance? So yes, I'm a mom of a 2-year-old and a 3-year-old, and where to start. I think the first thing I want to say is that the reason why I'm still here is because of the support and the understanding of my lab and my institute and everyone else that work with, the collaborators, because it has been an impact. I would not take it away for anything, but we have to have an honest conversation that it does impact you. And I think being as prepared as one can be to have the family and do science is the best that we can do. But yeah, it has definitely thrown me off balance, just physically, mentally. It's a tough job, but having a family on top of that definitely didn't help reducing the challenges. I wish it would be like a highly competitive sport where it gives you resilience. I do hear some the female scientists saying that in long term it does give you these skills, but because maybe my kids are still small and we're still in this period where it's really intense, it is I saw it more as an additional challenge, right? Rather than strengthening some of the skills that I already had before. So I'm honestly still in the process of finding that good balance. I'm in the lab, I'm enjoying what we do in the lab, but I do have to leave early because I have to care of the kids. When I care about the kids, of course, I think of a lab and all the issues and the questions that we have in the lab, and I can see in my kids' eyes like repeating twice the same question, and I haven't been listening to them. So I think it's just that's my personal experience, but resilience maybe is what's common with Jenny's situation is you power through, and that is only possible because I feel like I have the support and the understanding for everyone I work with, and if I'm also honest and say, look, I won't be able to come in, or this is going to be delayed, and across the board, I have understanding and say, yeah, it's fine, or support. So being honest with that, I think is really crucial because it is a challenge and it's very disruptive.
Mirana, in your video introduction, you mentioned Rosalind Franklin, whose work contributed to the discovery of the structure of DNA, but she wasn't given as much credit as Watson and Crick. So in your experience, do you feel that women are still sometimes in the shadows or overlooked?
I don't feel like it. I think it's a fact. I mean, if you look at the number of women leaders, you see the disproportion. So in Rosalind Franklin case, she passed away before the Nobel Prize could be awarded, but it's really, I encourage everyone to read her biography because all these issues at that time addressing, how she might have been overlooked, how work might have been overlooked, but on the other hand, Watson mentioning that, she would have already been awarded a Nobel Prize, was she alive at that time. Very interesting, the dynamic, and I think the issues raised back then there are still valid now. So it is, that's the thing, like we, in our institute, we do try hard to have as many female leaders possible, during recruitments, but the matter of the fact is in our institute, we have 4 females for 20 lab heads, and it's the same across universities and, other institutes. So I think, yeah, it is a fact. It's not just an impression that I have.
I can add a comment to that as well. So yeah, definitely there are obvious discrepancies between men and women, especially in their leadership roles. But saying that, I would say, especially in Australia, there has already quite an improvement been achieved. What Mirana just said, 4 out of 20, yeah, is obviously nothing then not good, really. There should be more. But if you go to other countries, there would be 0 out of 20 or maybe 1 out of 20. So in my opinion, I think here in Australia, there's already good starting support and really an initiative. Like just today here, this platform you providing us to really talk about our science and presenting ourselves here is really a great opportunity we have now here in Australia, and we really appreciate that, obviously. And there, I think even here in Australia, we are already maybe a little bit ahead of many other countries. But yeah, obviously, there's still a lot to do. But the other question is obviously also, what is reasonable to achieve? So obviously, yeah, we want to have more women, but like for me, a ratio 50-50 is just at this moment not reasonable to say really we need to get there, but really to support really the women to show it's possible and so on is absolutely critical.
Yeah, and it's also not about just getting the numbers, getting the women coming into science. It's about, having an environment that they want to stay in as well. Would you say, so I'll throw this question to both of you, would you say that the work environment has changed since you entered it, and do you think it's going to be different for the younger researchers coming through now? Obviously, you've touched on the fact that Australia is different to other places, and Jennifer, you had different experiences here in Singapore. But maybe we'll start with you, Jennifer, and then I'll throw it over to Mirana. What would you say about changes in the work environment?
It's a little bit difficult for me, obviously, to answer because every career step I did even on another continent, yeah? So therefore, obviously, the entire situation environment is anyway different, yeah? But for example, I did, 1 year ago, I did travel back to Europe, to Germany, where I also went to different institutes, give a talk also to my old institute. And basically, it was exactly the same. So also there, really for me, it was like I was put almost 10 years back, yeah. So I think overall, I would say it hasn't really changed a lot. But obviously it's very, dependent where you are and so on. So there's definitely more that can be done.
And Mirana, have you felt that the workplace has changed somewhat?
Yeah, there's definitely more to be done. And maybe to answer that, I'll share my personal experience again with motherhood, which for me was the major impact, right? So, one of the students I was mentoring when I started the lab, once mentioned to me, I would like to have a family, so I'm not sure whether I want to be a lab head. And this really shocked me because I thought I couldn't believe that we're still thinking that way, that we have to choose, right? So when after that I got my family, I realized how difficult it is. And so what I realized one of the major impact is the pressure that we actually put on ourselves, and also the fact that we're not vocal about it. So what I think is going to change is that we are getting more and more vocal about how hard it is. That doesn't mean that we shouldn't be doing it, but again, it's about being prepared. If we know how the impact is going to be, we can be prepared for it, and then, as Jenny said, be organized, have plans to face the disruption as best as we could. So I think it's going to get better the next generation, because there is not this omerta anymore to speak about, for me, things like, just every experience is different, but, morning sickness during pregnancy, how can you be 100% functional when physically you're not right? So it just being vocal about that, but we don't talk much about that because, it's not somehow right to talk about, issues related to maternity or, and I admit myself, I have this pressure. I'm telling myself, I don't want to put the maternity card on the table, but it's just the reality of it. So I think being vocal about it is not easy, but that will help change people's mind. And then when we share, other people have a better understanding of the situation as well. And then in return, this better understanding will allow, more flexibility, and people being more comfortable, and then more women being encouraged to continue because we fully understand what the challenges ahead are going to be.
Yeah, you're absolutely right about it being important to be vocal, and we all, I think, need to be a little bit more vocal. And I'm so glad that there are all of you here today, participating in this conversation. Just a reminder that you can ask questions. I don't believe any have come through. So speaking of disruption, so Mirana, you were talking about a career a major career disruption, being pregnancy. But one that has affected all of us this year is COVID-19. What impact do you think that COVID-19 has had on women in academia? Do you think it's exacerbating existing inequalities for women and other underrepresented groups?
Yeah, absolutely. And this is, this is actually data from our amazing gender equity committee and at Monash University and at RME. We do have data showing that women are more affected than men because of COVID. Just because, more, traditional roles, being at home are usually, performed by women predominantly. So it's inevitable that, if you're all staying at home, women will be more impacted. So this is my, as I say, this is there is data coming out, from these studies. It is proven that it has affected women more than men. So it's unfortunate, but yeah, it's behind that is, I guess, the cultural, habit that at home female do a bit more than men. Hopefully that is definitely changing, but the trend is still there.
Jennifer, did you have anything that you wanted to add to that?
Yeah, I mean, overall, we must also say COVID has affected everyone, no matter gender, age, race, or something like that. Everyone is really affected by it. And I think we see now really the obvious effects on certain groups of people. But I think it's really the long term where we see really then the impact is coming out. So I would say really we should really take that maybe as a chance right now to show that it's not happening as a long-term impact. Yes, at the moment, especially the mother probably had to stay at home, there's more homeschooling and so on, taking care of the kids. But this, as COVID-19 hopefully slowly gets under control, that this immediately stops, that this is then really, we can really show and so on. Now really everyone gets back on track on equal levels and possibilities. And I think we should really think maybe in that way and trying really to show now that it's actually everyone will be really given the same chance to come out of this situation. But yeah, I mean, it's not easy.
Thank you. We have a question from Sal. Sorry if I pronounced that incorrectly. You've both touched on your experiences maintaining a work-life balance, but I might just phrase this question a little bit differently in terms of science is ultimately a competitive endeavor. We're competing against each other for grant funding, for the publications in the best journals and that kind of thing. So people are fighting to be first. How is it that we can achieve work-life balance? And maybe I'll sort of spin this question, given that you've spoken about your own experiences, how do you think in general it can be possible for women particularly to achieve a work-life balance?
I really honestly don't know if I have that balance. As I said, it's really, I'm still in the exploration phase where I don't feel that, my life is very balanced right now. I feel really torn between, these two lives, the science and the family. And I feel like at the moment I'm just playing catch up, really, to be honest. So it is competitive, and I do believe that, that competitiveness is solved by excellence in what you do. So I think the reason why we still get grants and the reason why, we have our papers out is because of the excellent work that, the lab is doing, the people in the lab. And the price to go to get there, it's maybe ask me in 5 years time. But yeah, at the moment it's pretty much I'm just playing catch up. We did have events. I went to events where actually, we had panels of women from at different stage of career, and women, who made it, who have children who have grown up, barely remember this time, because they made it and then they were successful and they feel balanced. So I do hope to reach there, but it's I guess it's this difficult time. It's just intense, on all directions. So as Jenny said, resilient, just powering through during these times is the key, and doing the best we can during this time. Yeah.
I think it's very important that you learn to set yourself somehow boundaries or somehow a schedule. They really say, okay, whatever happens in the lab in the evening or so, I have to go home to have dinner with my kids. So for me, I have to go in order to meet my team to have my training session. Yeah. So that you really have this kind of schedule where you, no matter what happens, you do the other thing. But on the other hand, science, I mean, I always say for me, science is not a job. It's only one, yeah, it's a passion and also for me a privilege that I'm allowed to do that. That's something very special, yeah, our jobs. So for me, if there's something exciting going on in the lab, like on Friday afternoon, a great experiment and so on, and we just want to know what's the result, yeah, what is coming out of that. There is, for me, it's not a sacrifice to go on a Saturday or Sunday into the lab in order to continue that experiment or whatever needs to be done. I do that with a lot of pleasure, and that's what I want to do at that moment. So when you ask me, what do you want to do now? It's not that I want to go out, have an ice cream or whatever. No, nothing can hold me back to go to the lab and finish that and knowing what's going on, yeah. So yeah, I must admit, I work much more than many other non-scientists or whatsoever. But for me, it's really what I want. And this is again about passion, what we said from the beginning on. When you're passionate about the work, you do these sacrifices, but you would never define yourself as a sacrifice.
Oh, thank you. Celeste agrees in that encouraging young women to be vocal is absolutely fundamental to changing the current male-dominated workplace. But Celeste asks, what about mentoring and raising young men to be supporters for women to make sure that the next generation of men still don't carry these same gender biases that are current now? Jennifer, did you want to start?
A very good question. I think that's really the key we need to work on, because now the system we are put in is built by men. So really how to self-promote, how to really articulate yourself and so on is the way how men are doing it, I would say. I don't say it's good or bad, it's just a different way. Yeah, what Mirana also said, usually I would say in general, women are less vocal. If there's something going on that is a problem, like something they have to deal with, they deal with it. They shut up, they do the job, they try to get out of it and continue their work. And also, really, I very often have the impression women are really have a bit more humility, so they are not really going out there and self-promote them. So saying, I'm the best, I did that, and so on. So for me, it's more important that my actions are actually speaking. Yeah, that when I achieve something, yes, then it's obviously somehow a sign I did something good or so. Or more important, that really my team is really coming together and that my team can really show what they can do. And I really want to stand more in the background. So, I mean, that's maybe a few examples how maybe men and women, at least in my opinion, yeah, it's obviously a very personal opinion, how things can be obviously a little bit different. But we are now put in the system that we need to behave like men do in a leader position. And this is obviously because it was built up by men. So obviously it's really important that now, obviously from the beginning on, from the younger generation, it will be built up together, that there's really an equal input and so on, how things are done and so on, and that also younger men really have the same respect, acceptance between leader women and so on. I mean, for me, just as an example, I don't know if that's really a general thing also, but applications I receive from people that are interested working in my group, 95% are really female applicants. I hardly get any male applicants. And that's for me a strong sign still that there is a gap between really the acceptance and respect of a female leader in the overall population.
Mirana, did you have anything that you wanted to add?
Yeah, I do like Celeste's question. I mean, who needs support, men, men or women, in science? And again, speaking of my personal experience, with my major challenge, which was the maternity, we, things have changed, and my partner does 50-50 as much as he can, but acknowledging coming to work and acknowledging that, well, I'm sleep deprived because I have to help fed the baby during the night and I've slept much. how is that, it did feel a bit, not very comfortable to admit that, but that's exactly what we need to work to support men, to say, it's okay if you also help, it's okay if we share. And I think the obstacle is that we need to encourage men to take, parental leave. We need to put things in place so they can take parental leave, so that bias, gets reduced. So we all do, at the end of the day, 50-50, right? So I do like this idea of supporting men, and actually, in all our gender equity committees is one of the avenues that we explore, to how to support men around, the maternity, and so to take more parental leave, and so things, the way on the women is lessened in a way.
Well, Joe says that the husband does the laundry, so hopefully that's a help for you, Joe.
Exactly.
Someone else asks, what do you see as key barriers to achieving success that you've had to overcome in your careers?
I come from an engineering perspective, of an engineering training background, mostly male, computer programmers. I didn't feel different back then because we're all nerds coding. Then, postdoc in science or PhD in science, 50-50 female, 50-50 male. And it's when I started my lab that, of course, there's this discrepancy, right? But also the maternity was really, for me, what made me feel like it's a bit more difficult for me as a woman than if I were a male, to be honest. So for me, until then, there was no obstacle at all. We're just doing science. We're passionate about what we do. I didn't pay attention to gender differences. I felt like we all had equal opportunity. But yeah, this is really when it has impacted me.
Jennifer, you mentioned a couple of barriers that you had to overcome as well. How did you go about overcoming those?
I always had great support to do my scientific work, really the work at the bench and so on. But there is really, in order to get to the leadership position and so on, much more that people in earlier stages should really maybe explain or prepare you for. So obviously, especially when you're in a postdoc situation, yes, you need to deliver really good scientific work. But if you get already there really a supportive network that you can already start becoming a little bit independent, or really being able to show and go out that it was you who did the science, and that you can really go out and present your own work and so on. This all contributes obviously then to become a leader. And there obviously I received no support at all. Like I was thrown in a completely new job here as a leader and so on. But there I think is really, for these transitions, really there's really something where it makes a big difference where you come from and so on. And again, when you really change the research environment between continents, countries, and so on, it's very different just to understand how all this education system is really working and so on. So just coming here to Australia, I mean, also then trying to understand this, all the different students and so on, how the university system really works on the lower, on the earlier levels, was really very difficult for me. But that's always something really basic you need to understand. So I think there's really very additional support you need to receive. And there obviously, I didn't receive any.
Maybe as a final question, to end on a very positive note, Jen says that she would love to hear what both of you are most excited about right now. So Mirana, what are you most excited about?
Hey, surprise, surprise, passion, the data again. I guess you will come back to that. You come to this at the end of the day, right? So yeah, as I say, I'm passionate into new tools, new computational tools, and there's a new technology right now where we can interrogate our genetic information in 3D. So before when you do a genetic testing, you take your blood and then you get your information. Now we have technologies that allow us to do that, in all organs and in 3-dimensional. It feels, we had discussion with Jenny, it feels like our two fields are going to merge together, because not only the cellular architecture, but also the genetic blueprint behind it are now, coming together because of technology. So I'm super excited about the new data that are going to come up out of these technologies, which are called spatial transcriptomics, spatial genomics. So this is for me the new frontiers. Not only we look into our genes, our cellular structure, but then we can put all of this information together as a whole organism, not just a single cell or a specific cell type, just the whole picture together.
Yeah, and certainly it makes for a fantastic presentation when you can show those images. Like both of you have such colourful, lovely, three-dimensional sort of images going on. Jennifer, what are you most excited about?
So as the question is excited about right now, so what I really want to do now, obviously when the great conversation has finished and so on, I just want to go downstairs to the microscope, because right now my PhD student Azel has a new embryos got delivered this morning, and if you see just once in your life how really one cell starts to grow into real life, it's you just want to see it over and over again. And we are just testing right now a new marker we have never looked at again that might be hopefully traffic transported along these framework, the cytoskeleton inside the embryo. So that's right now what she is doing, and I can't wait to see these beautiful images again and over again. And also saying that obviously, my legs are still quite sore from my bike session this morning, so I'm happy just to be a bit, sitting down and watch. So that's definitely something I can't wait to do now.
Well, thank you both, Dr. Jennifer Zenker and Associate Professor Mirana Ramialison. Thank you for sharing your thoughts. And really, when we're thinking about diversity inclusion in STEM, it begins with conversations. It begins with thinking about experience of others. So thank you for sharing your experiences. We definitely all need to support each other, especially as women, but we also, as people have touched on in the chat and the questions, we need men, we need gender diverse people in these conversations too. We also need role models, as people have sort of touched on as well in the chat. And I think both of you are excellent role models to young aspiring women who are thinking about moving into biomedicine. So everyone, you can continue the conversation on Twitter. So thank you, Jennifer and Mirana, for kicking off our inaugural Women in Biomedicine event. And thank you all for attending.
Thank you, Katrina, and thank you for the question. It's been really nice to share.
Thank you, everyone.